Welcome to section 6.5. In this section we'll be learning to solve rational equations. The key word here is equation. This is a different approach from what we did when we were solving expressions. You keep in mind that when you're solving an equation, you can do really anything you want to do to it as long as you remember to do the same thing to both sides and keep it balanced. The beauty about these problems is that if you multiply both sides of these things by their LCD, when you go to reduce it, it actually eliminates the fractions, so that all you have to do is just work with a nice, easy linear equation. Maybe sometimes you might have a quadratic equation. But the idea here is that I would put a note that we can eliminate fractions from equations if we multiply both sides by the LCD. Okay? So it's very important to be able to figure out what the LCD is. In this example, I've got a denominator of x plus 1, a denominator of 4x plus 5. If I could factor either one of those, I would. However, there's nothing I can do to factor x plus 1 or 4x plus 5. So that means the LCD needs to include each of these denominators. So my LCD is going to be x plus 1 and 4x plus 5. Okay, so my LCD is x plus 1 times 4x plus 5. Before I continue, however, we do have to be careful in these types of problems. It is possible to get a value for x that would not work because it's not part of our domain. For example, if you look at this first denominator, you'll see that if a value of -1 for x would give you a denominator of 0, which is undefined. So we actually have to think about restrictions for these problems. A restriction on the domain would be anything that if we were to get it as a value of x, we would have to throw it out. And I'll say that you might have no solution sometimes. It's possible. So in this particular case, we do have a restriction. X cannot equal -1 because it'll give us a denominator of 0. Also over here, you have another restriction. If you set your denominator equal to 0 and solve for x, you'll find you get a value of -5/4. So we have two restrictions, -1 and -5/4. Okay, how did I come up with that? Just set 4x plus 5 equal to 0 and solve for x, and you'll get -5/4. Okay, so this means that we're going to go through and solve this, but if we get either one of these answers, we're going to have to throw it out and not use it. So let's see what happens if we multiply both sides of our equation by our LCD. And I really wish I had another color. I'm going to pause the video and see if I can find one. So I'm going to multiply both sides of this equation by my LCD, x plus 1 times 4x plus 5. So I'm going to write x plus 1 times 4x plus 5 times 3 over x plus 1 equals. And then I'm going to multiply the right side by the LCD. So I'm going to put over here x plus 1 times 4x plus 5. Okay, you can think of all these as being over 1. But you're going to notice that when you multiply both sides by the LCD, the fractions are going to go away because you've got a factor of x plus 1 that you can reduce with this x plus 1. They're gone. They canceled out. So I've got 4x plus 5 times 3 on the left side. On the right side, 4x plus 5 cancels with 4x plus 5, and I'm left with 9 times x plus 1. Okay, distribute, that's going to give me 12x plus 15 equals 9x plus 9. And now if I solve this for x, I can subtract 9x on both sides. I get 3x plus 15 equals 9. I can subtract 15 on both sides. And I get 3x equals negative 6. Now divide both sides by 3. I'm getting x equals negative 2. So the first thing I do when I get my answer is I go back and look at the restrictions that I had. My restrictions were x could not equal negative 1 or negative 5/4. Negative 2 is perfectly acceptable, so my answer is x equal negative 2. Okay, I'm going to do one more example like this, and then I'm going to turn you loose to practice. My second example, we're going to solve 3x over x plus 1 minus 5 over 2x equals 3 over 2x. Okay, so what is my LCD? Can I factor any of these denominators? If you can factor, then you need to. However, x plus 1 and 2x, neither of those factor. So I'm just going to include each of those as part of my LCD. So I need to have the 2x in there and the x plus 1. Okay. Now I'm going to multiply both sides by my LCD. And I'm also going to be distributing. So if you want to think of this as multiplying each fraction by the LCD, you can think of it like that. I'm going to write it out so I can see it. So I'm going to say 2x times x plus 1, which is my LCD, times 3x over x plus 1. Okay, minus, I've got 5 over 2x, and I'm going to multiply by the LCD, 2x times x plus 1. We'll put that as over 1. Equals, I've got 3 over 2x, multiplied by the LCD. So I multiplied each term by the LCD. Just be careful. Make sure that you remember this only works if you have equal signs in here. If you don't have equal signs, it's a totally different set of rules and you cannot do it. Okay? So, in my first term, x plus 1 cancels out. I'm left with 2x times 3x, or 6x squared. In my second term, 2x and 2x cancels. I'm left with negative 5 times x plus 1. And then over here, the 2x's cancel. I'm left with 3 times x plus 1. Okay, so now I have 6x squared. I'm going to distribute. That's minus 5x minus 5 equals, distribute, I get 3x plus 3. And now I need to combine like terms. So I'm going to subtract 3x on both sides. Or, I need to get, I'm sorry, let me rephrase that. So how do I know where to go from here? I've noticed you guys, or just students in general, get to this point and they're not sure where to go next. The key thing that you should notice at this point is you have an x squared. Since you have an x squared, that means you have a quadratic equation. How can you handle a quadratic equation? Well, you might set it all equal to 0, get it in standard form, and solve by factoring. You might use the quadratic formula. If you're comfortable, you could complete the square if you want to do it that way. I am going to get everything on one side of it, and I'm going to try to factor it, and we'll see if that works first. So I'm going to subtract 3x, and I'm going to subtract 3. So that's going to give me 6x squared minus 8x minus 8 equals 0. So I'll start looking at how I can get this thing to factor. I noticed that I have a GCF of 2 that I can pull out of each of these. So that leaves 3x squared minus 4x minus 4 equals 0. And then I'll see if I can get this to factor. So if I do 3 times 4, it gives me 12. I want factors of 12. that would give me a -4. These are the only possibilities that I have. To get a -4, I could do a -6 and a +2. So I'm going to write it as, expand this with 4 terms. I'm going to say 3x squared plus 2x minus 6x minus 4 equals 0. Alright, and then looking at my first 2 terms, I can pull out x, leaves 3x plus 2. Over here I can factor out -2. That leaves 3x plus 2 again. So now I have a common factor of 3x plus 2 that I'm going to factor out. Now this 2 sitting out here, my GCF is still going to be there. So I've got 2 from the GCF that I'm going to factor out my 3x plus 2. And then I'm left with x minus 2 on the inside. That's all equal to 0. Okay, so this is just basics for solving quadratic equations. At this point, you're going to set these factors equal to 0. So you've got 3x plus 2 equals 0. Or x minus 2 equals 0. And I'm going to subtract 2, divide by 3. X equals -2/3, and x equals 2. Now when I started this problem this time, I forgot to do something very important. I forgot to write down my restrictions. So let's go back and see what my restrictions were. Restrictions, if you recall, are numbers for x that would give you a denominator of 0. So you have a restriction that x cannot equal -1. And then over here, x cannot equal 0. Okay? The answers that I got were -2/3 and 2. So those answers are okay. I don't have to worry about restrictions. Okay, so those are my answers, -2/3 and 2. Okay, I'm going to stop here, but I am going to give you a hint, or I'm going to give you an assignment, and then I'll give you a hint to help you with some of them. Okay, so on textbook page 344, your assignment is going to be page 344, problems 15 through 30. And okay, so actually I'm not finished. I've got to do another type of example. Okay, so you're going to be doing those problems. When you come, just remember that before you find your LCD, sometimes you might need to factor one of your denominators. So just keep that in mind. That's my hint, is just make sure you remember to factor all your denominators. And there is one more type of example that I'm going to show you. Okay, so the last example that I'll be doing with you from section 6.5, this is what sometimes referred to as a work problem, work with a K. I'm going to read it first and then I'll explain how we're going to complete it. You can complete the yard work at your friend's house in 5 hours. Working together, you and your friend can complete the yard work in 3 hours. How long would it take your friend to complete the yard work working alone? So these types of problems follow a very consistent pattern. There's a rate that's given for one person working by himself. There's a rate, sometimes it'll give you 2 individuals working alone, and you have to find how long it would take working together. In this case, we're given a time when one person's working alone and then a time when the 2 of them are working together. There's a formula that can be used for these problems. 1 over the part plus 1 over the part equals 1 over the whole. Okay, this is derived from, I can't remember now, I'm sorry. But the work problem is just 1 over the, so the parts are going to be the individuals working alone, and then the whole is if 2 or more people are working together. So you can do the work alone in 5 hours. So that means the part here would be 5. So you would say 1 over 5 plus, Okay, now we don't know about your friend. We don't know how, we know that if you work together it's 3 hours, but we don't know how long it takes your friend to do it alone. So we're going to let your friend, we're going to let X equal the time your friend needs. Okay? So maybe your friend can do it in 2 hours, okay? Or maybe he can do it in 6 hours. So he's going to be, so X is going to be the friend working alone. So we're going to say 1 over 5 plus 1 over X equals, and then 1 over the whole. So this will be if the two people are working together, you can complete the job in 3 hours. Okay, so 1 over 5 plus 1 over X for your friend equals 1 over 3. And then we're going to solve this. This is a rational equation. You're going to solve it just like you did the other problems in this section. You need to find your LCD. You've got a 5, an X, and a 3. So your LCD is 15X. Multiply each of these terms by your LCD. So you'll say 15X times 1/5 plus 15X times 1 over X equals 15X times 1/3. And you could put each of these 15X's over 1 to help you if you need to. Alright, so you're going to divide 5 into 15, goes 3 times. So you have 3X plus, here your X's cancel. You're left with 15. And here 3 goes into 15 5 times, so you're left with 5X. Okay? And then subtract 3X on both sides. I've got 15 equals 2X. Divide both sides by 2. I'm getting 15 halves, or 7 1/2, or 7.5 equals X. So this means that your friend working alone would need 7.5 hours. So the practice problems that you need to do that go along with the work problems are going to be found on page 345 from your textbook. You're going to do problems 33 and 34. And do not worry about the way they're explaining it. You don't have to fill in the table. If you prefer to use the formula that I've given you, that's perfectly fine. So page 345, numbers 33 and 34.